For every food you eat, there are processes for breaking it down into its component parts, moving these through the body, and using them. For example, if you were to eat a bell pepper, initially, secretions from the salivary glands start breaking down starch into smaller units. There may be a sweet taste on your tongue at this point, that slight sweetness you notice when eating a piece of bread. This is because the sugar maltose is being liberated from the larger starch molecules. Once you swallow and the partially digested food reaches your stomach, a little bit of the salivary enzyme, salivary amylase, is still acting on it, but quickly gets deactivated. It stops functioning because the acid in your stomach denatures the enzyme. So there really isn't a lot being contributed to the carbohydrate digestion process in your stomach. It really only picks up again when the food makes its way into your small intestine. Most of the starch gets broken down to disaccharides in the small intestine. Another enzyme, pancreatic amylase, plays a key role here. This enzyme breaks the remaining starch into disaccharides, and then other enzymes from the cells of the small intestine break these disaccharides down even further into the monosaccharides glucose, fructose, and galactose. This is really the end of the digestive portion of the process. The monosaccharides liberated in the small intestine are absorbed through the intestinal wall into the capillaries, and from there they enter the portal vein and make their way to your liver. Once they're there, galactose and fructose are further converted into glucose. And this is the form of carbohydrate used throughout the body to generate energy, or the form used in the muscles or liver to link up multiple units of glucose to store as glycogen for when you need glucose later for energy provision. So that's it in a nutshell. Your body converts, uses, and stores carbohydrates, and it's really very efficient at it. We are 95% efficient at absorbing the carbohydrates we eat.